install. So the IDV I'm demo right now is version 5.7 update 1. That is in our nightly release. So if we go to the nightly release, you can see the Unidata download IDV. So this is the nightly release. So this is 5.7 update 1. So that will have the most updated or new feature I just added for the last few months. So after install, the installation is very simple. Just click, click, click. And then after install, I have this in my application. I have many versions here, IDV. So if I expand that, run IDV. So since I noticed that probably not many big IDV user in the committee, so I will give it very, very brief introduction and then jump to do some demo of the real data stuff. So IDV, when you run, you have this two window showing. And this, what we call this one is a control window, and this one is a display window. By default, the display window will show the map view. But if you need to create some group view, you can easily just, by a few steps, you can have this group view to display. So I close this group view. And for the data, IDV can be able to access many, many different data. So the user, the good thing for the user is you don't need to worry about the data format, projection, the frequency, or all those kind of things. IDV has a very smart way to handle. And in this data chooser, the first one is a quick link. You probably don't need to worry. And the data chooser will have the local file. You can access local file. And for the catalog, you have most, we talk to the Strat data server, and we also talk to the Ramada server. And the directory, also the local. For the satellite and radar, we're using IDV most talk to the ADDE server. So we have a lot of ADDE server built in here. So this one, adde.uca.edu, is the one in we supported in the Unidata. So another one is very commonly used is atm.uca.edu. And in the other like GLM data and radar, we have this interface. You can like it's also through the Strat data server. So you can click, select any radar file as source, and then use all those variable available, only one times that most recent. And you can see hopefully there's somewhere there down there. Yeah, there's a lot of stuff. So this is the radar. So let's clean that out. And we also provide the point data. The point data, and we need to go to the ATM or something, connect that. So we have a lot of point observation and the sounding data. So that is a very brief, give you some idea what we have here to support and what can be done to create those display. For this demo, I will probably, the first thing I would like to show is some kind of more interesting weather event happen lately. So one thing I think is everybody will be interested is the fire we have in Oregon, California, Northern California. So we will go to the NP goes through the ADDE server. We can see those fire. NP goes as, okay, let's connect it. Then we select this image type. One thing we want to select is not the individual channel. We select the goes west corners all band. So that is the multiple channel. So just select 5 most recent. If I click as source, now we have this all the like 10, 15 channel of the data. But we also have the derived variable we get depends on those channel data. So one interesting this derived variable or the product we have is the fire temperature, API fire temperature. So we have this 5 most recent, and then we can grab subset the region. The data is very big, and we need to get the 5 different channel. So we better subset that to the small region. We probably feel like we will get the very good the fire event there. Then we click the create display. We will come in, getting the data. Now at the bottom here, you'll see that we're reading the data from the ADDE server. So that is not in my machine, that is going back to the server. Oh, sorry, the resolution, I should change that. Let's remove it. Oh, okay, so that's I need to change the resolution, so it's better for better result. So with higher resolution, that basically is full resolution of the satellite data. It's take a little longer to download from the server to my local machine. And I think got the data, all the data. Now if we zoom in this area, you can see all those interesting high temperature area, like those fire region. It's quite interesting. The smoke, you can see the smoke, you can see those fire spot. It's high temperature. It's not what we are showing is not the visual fire. It's actually is the temperature of that location. So you can see all those locations. If we put the map on, so you can see better this Oregon region and Northern California. So there's a lot of fire spot here. And also the smoke. I'm not sure how the screen sharing you guys can see those smoke or not. From my local, I can see those smoke come out those hot spot. Okay, so this is the first thing I want to share to show. Any question here? Okay, let me remove those. And another thing I'd like to share in the summer, we also like to see the GRM, the Lightning. So you can select the Lightning from the ADDE server. So source Lightning, model. So it should be okay. So when the data come in, IDV will automatically adjust the projection. Depends on do we want to use the projection of the data, or we want to some kind of fixed projection. Those projection and coordinate change will be done automatically inside IDV through the NextCDA Java library, and also some of it through the visAD library. Let's take a little bit for this Lightning. Time. Yes, please. Lightning data download is normally a little bit slower since each file in the data server is only a few seconds. I think 10 or 15 seconds. So we got all the data done. And for the IDV, again, I said this is a 2 screen, and we have this display screen, and we also have this like the control window. So if we want to, right now you can see the lightning is not very dense. So because this thing, if we decluster that, so we can see all the data showing here. Okay, so this is the lightning we have, and another thing I like to show that clean that out is the one of the latest development is what we call the crossing subset. The crossing subset is we get using the data through the shared data server. If we go to the GFS and then the 1 degree, and we can select the forecast best time series. And here, if we download at source this data set in the IDV, and at this time, what we are showing is the grid data set. So it's like if we bring up the property of this this data set, you can see this is the coverage, spatial coverage of that data set, and we cannot flip the longitude coverage. It's basically from the 0 to 360. So there's cannot do any flipping. So this is the original grid GeoGrid data set. So if we specify this the same data set as the grid coverage here through here, the data source type we can bring down. There is a type called the grid coverage, and now with S source here, and we can see the bring up this property window. The spatial subset we can flip. Right now it's from negative 180 to 180. So if we flip, this is what the data set original coverage is from 0 to 360. If we flip it, now we can cross the 0 longitude. So this is what we call the new crossing subset feature in IDV. So we can select a region here, cross the boundary, the data set boundary. So if you say, okay, now everything we display here will be in that region. So let's try to bring one of the wind speed here and select a few time step. This is the time subset panel, and this is what display we want to create. We want to create an ISO surface of this derived variable speed. And now we can set create display. Oh, this is probably a little too high. I need to subset the level. Okay, so it's also need to read the volume data of that region of 11, total 11 time step. We already finished the U component. Now we read the V component. The first time is a little bit slow. Okay, so this is a little high. I need to subset the, sorry, the level is only the 100 millibaud to bottom. That should be faster than first time since we are getting smaller data set here. Let's take about, I think here is about 1 second for each time step of one component. See. Okay, so this is better. So this is the ISO surface of the wind speed for the volume. So we can like smooth that a little bit, change the value to like 30. This is the wind speed. And if we want to add other variable or other display like the cross section, vertical cross section, we can create the vertical cross section. So the same, this is a lot more faster. So this is cross section. You can change the interval to 2. This is a little better. So this is the display. So you can see this cross section through this view window or through this control window. And we can easily change the location of the cross section here. So you can drag, go to anywhere. And so I can see this. Let's create one more like vector through the display vector plan view. Color speed level, just the bottom. So that also be very quick. So it has the full 3D display. Change that to Streamline. Yeah, the whole 3D all this 3D display is actually created through this grid coverage data source type, and this grid the coverage also the new API enabled in the I think is the next CDS Java 5. Through the 5.0, and the library we are using here is 5.3 or 5.4. So that should be, I think that's probably also available for the Python user if you want to create those coverage type. This cross the boundary. And so this is something. Oh, another thing I'd like to show is what we call the this 2D variable for the moisture the total precipitation. This total precipitation is in the is mixed interval accumulation. So if we want to do this mixed interval accumulation, so we need to normally we like when we if I just create this here, like the same time step, just create the 11. Let's just randomly create that. So you can see the region is same. Okay, so now create display. So you can see those total precip is kind of jumpy because the interval we do not know. Then maybe the 6 hour, maybe 3 hour, sometimes even 9 hour interval for those precipitation field. So you can see they are not consistent. So if we remove that, now this is the new stuff in IDV, you can have the derived variable called the time-step precipitation accumulation. So if we like select something and we, let's see, okay, this should be okay. So let me close the 3D surface. So you can see from if we display this, now the precipitation field display in the view window, they are all consistent with the time step is 3 hour accumulation. So IDV had using the library to create this the same interval, fixed interval accumulation for the precipitation that make it easier for the user to go through that. Okay, so this is one of the pretty much what I want to show, the coverage stuff, great coverage. Like to stop here a little bit to see if any question or what kind of display you like to see. No question?
I have a simple question. Is there an easy way to reverse the color bar?
Oh yes, the color bar is very editable. Like the color bar we have here, we have tons of color bar here.
But if you like one, but you just want it to be the opposite direction.
Opposite direction, you can go to the edit color table.
Mm-hmm.
And then you want to see like the, I'm not sure, it's the reverse.
Yeah, I was playing around with this the other day and wanted to reverse the colors for satellite viewing.
Satellite, we do have that reverse one. The satellite, if you do satellite,
it had a grayscale reverse, but it didn't have a
grayscale, and another is reverse grayscale.
Yeah. Okay.
Now we should have somewhere here. Very long list. Like great basic. Yeah, here is the inverse grayscale. This grayscale, there's inverse grayscale. So
but there isn't a way for me to pick a color bar and just flip it.
You do need to go through those editing process and create and save it. Once you save, you can use it forever.
Okay.
Yuan, the easiest way to do that is to change your range, flip your range.
Flip the range.
It doesn't enforce the range to be positive?
Yeah. Your range you can set to be anything. So if your range goes from 0 to 255 and you wanted to invert it, go from 255 to 0.
Oh, okay, cool. Thank you. That helps a lot.
Okay, does it inverse that? Oh no. So this is now 52. Oh yeah, that's right. Thanks, Tom. Okay, so this is the coverage crossing subset stuff. So that actually being used. IDV community have been waiting for this feature for a very, very long time. But finally, we make it available. This is one of the benefits of this pandemic. Since I'm sitting home doing nothing to do, so more concentrate my time on this development. And so this is another thing, the more fun part. So we'd like to show the 3D streamline for the hurricane. Okay, so this is what we have here. So let's go back to the file, the local file. I have downloaded this name corners 40 kilometer. So if I add this to the source, so this is the time when this hurricane about to land. So I grab this data from our thread data server because I know they are not keeping very long archive for those kind of data. So I download locally, but we should be able to find it somewhere in the NCDC thread data server. Just make it easier. So for the spatial, this server, we can bring up after loading the data, we can subset this small region to see this 3D streamline. This is pretty much the region of the hurricane before landed. So we say OK here and OK even. And now we can do the derive, go to the 3D flow vector. And in the 3D flow vector, we have the trajectory or we have 3D volume streamline. So you select a few time step, you don't want the whole, a lot of stuff. Also, you don't want the very high level, just subset the level. And this is basically all you need to do. Now you click Create Display, you'll get this Streamline to see. Yeah, so it's pretty quick. This is the hurricane, very clear, the hurricane structure. And the vertical scale is a little bit shrink since the ratio I put here is 0.4. After this, I probably move and then change the ratio to 1:1. That make it even better for the, I should change that before I click that create button. Okay, so let's showing that first. This is the, see the, now let me remove it. It's a little too crowded since the vertical ratio is too small. So the vertical ratio is 0.4. We can change that to 1. Now we come back here, create display here. So you can see very clearly the structure of the hurricane, the 3D streamline. Still rendering. Yep, we're done here. So Hurricane 3D Streamline for those dynamic structure here. And the color here is colored by wind speed. You can select any other variable to color those streamline. And if I select the level, just I don't want to see the whole structure, just the bottom level, 850 through the 950, those level. So you can see so this is also the structure we can see. We only create a streamline for the data from 850 to 950 level. So this is another streamline. Another thing I'd like to show here is the 3D trajectory. For the 3D trajectory, also for those level, if I see the region, and the color by speed. So that will give you this 3D grid trajectory. So the trajectory start surface, we can either set at the bottom here, like this is what we, if we're setting the trajectory from one level, it will come something like that. If we want to change that to XZ plan and then create trajectory. So you can see the trajectory actually come out from one of the vertical surface. And this is the offset length, we can increase that. You can see how. So we can also see from this view to see how this trajectory created this, formed this hurricane structure. And another thing I think we can do is either by tracer. Tracer also a lot interesting here. Yeah. So for the tracer, it's pretty much like every single time that it will, this same surface will release the same amount of the data point or the air parcel to go with the airflow dynamically. So I don't select too many times that. Okay, this is the one thing. And for the hurricane structure, the last thing I'd like to show here, let's remove everything, is the bundle. I just get it from, I got this bundle from Professor Brian May. He asked me a few questions a few weeks ago, so he sent me this bundle. So I just run this bundle without making any change. So this is basically point to the server to get the weather. So this is, I guess this is the bundle he used in the classroom with the data from the NAM, also from the NAM corners model output, and with all those information. So this is what he's using. So one thing he's using is all those tracer to see for those regions. Right now the tracer initial point is not very correct, so it somehow it's missed. It's not a bug. It's because the way we calculate the tracer, so we will have those initial point in some weird location. But once you have those, you can see this bundle goes through that. So this is the one good thing about the IDV. You can create this bundle, and this bundle, he sent me this bundle many weeks ago, and now I still run the bundle. I can still see the current weather. It's today's weather, not the old archive weather. As long as this bundle is pointing to the data server, this active data server keep updating the data, and the bundle will provide you the new display, the real-time weather. So this is what Brian may use in his classroom, and I think it's good to give this a demo. The reason I want to give this a demo is last semester I've been approached by two professors to provide the remote class to give them very basic training of the IDV for their students, so the student can run IDV in their home, and they also have the access to multiple data, tons of data outside in the server. Some of server is supported by Unidata, some server by other agency like the NCDC. So the student can have the data, can have the tool to go through the synoptic class. So this is, and I'd like to make one advertisement here. If any of you feel like it's good for your classroom and you need some basic training, I can give a 1 hour quick training for one specific type of data, such as the radar or satellite or some other remote data set. So I can provide this 1 hour class so the student can be very easy to go through those data and then create the display for their synoptic class or any other class. So that is pretty much all I have here. Any question or any suggestion? And by the way, there is also tons of the bundle created by we already have a lot of bundle inside the building with the IDV. So some of this the Brian Mapes bundle. Some of those bundle is actually I copied from Jim Steinberg. Some bundle is created by me. So a lot of stuff. Once you create it, you are interested to trace look at the real-time weather or make some study, you can have that automatically. And if you install some, if you like to see more bundle from Brian Mape, and you can install his plugin actually. We have the plugin for, Mape's IDV collection. So there's a lot of bundle he created for synoptic or for climate study.
Well, this is Alex Davies. I have a very basic question as a non-IDV user. How easy is it to point your software at a specific server? You know, like if you have your own thread server on campus and you're hosting some sort of your model output or something along those lines, like how easy is it to point it and ingest data from sort of one-off servers?
Very just one line, just like you do in your browser. You have here you have the catalog. Right now it's HTTP thread UCA-edu catalog.html. Replace this line with your server URL. You're done. Everything is there inside that server.
Okay, great. And it's only compatible with thread servers?
If you can type in your thread server, right now I can paste that to see whatever. If you have a thread server.
No, I don't run a thread server and my machine's down, but I'm just curious in general, like it's compatible with only threads servers, is that right?
It's Ramada server too. Thread server, Ramada server, map server.
Okay.
Web map server, yeah. But
Great, thank you.
it's not being used a lot, web map server.
Cool. Thank you very much. Very cool.
Yep.
I learned a lot.
Any other question? I guess we are finished here, so we can enjoy our afternoon.